In this video, we will be learning about Nmos pass transistor and how it works, how it passes weak 1 and strong 0. Here is a simple circuit. It is just an Nmos transistor, which is also called as Nmos pass transistor. We have three terminals, gate, source and drain for an Nmos transistor. But when you call it as Nmos pass transistor, the gate terminal will be the same, but the source and drain will be interchanged based upon the voltage in source and drain terminal. Therefore, we just mention it as input and as well as output. So, if you want to learn about Nmos pass transistor, we have to remember three different conditions. First one, this is an Nmos transistor. If you want to switch on the Nmos transistor, then VGS must be greater than or equal to VTN. We have to remember this equation. What is VGS? VGS is nothing but voltage between your gate and source, which is called as VGS. And there is another term called VTN. T stands for threshold. Therefore, this is a threshold voltage, VTN. N stands for Nmos transistor. Therefore, VGS stands for gate to source voltage. VTN stands for threshold voltage. Therefore, VGS must be greater than or equal to VTN to switch on Nmos transistor. This is the first condition. Second condition, we generally write it as input and output. But which is going to be the source terminal and drain terminal? In order to determine that, first we should have the knowledge about the voltage in the terminals. The terminal with highest voltage will be the drain and the terminal with lowest voltage will be the source. These three conditions we have to remember always. With all those ideas in mind, let us now consider an Nmos pass transistor and try to ascertain how it passes a weak 1 and as well as strong 0. So first condition, we are going to check why it is passing only weak 1. In order to get knowledge about that, we have to make some assumptions. Look into the figure. We have an Nmos pass transistor. We know that this is the gate terminal, which is mentioned as VG. For the gate terminal, we are going to supply logic 1. Logic 1 means plus 5 volts for our assumption. Therefore, which is equal to VDD. So, look into the statement here. VG is equal to VDD, where VDD is equal to 5 volts. We also assume a threshold voltage for this Nmos transistor to be 1 volt. Now, back to the figure. We always know that this side is going to be the input, the other side is going to be the output. At the output, we are connecting a load capacitor. The voltage in this capacitor is mentioned as Vc. For our assumption, we are initially discharging the complete voltage, the complete charge in the capacitor and mentioning it as Vc equal to 0 volts. Therefore, Vs becomes 0 volts. On the other side, right now we are about to check whether this particular Nmos transistor can pass 5 volts from input to output. This is what we are going to check. So this side we are going to feed in 5 volts, which is equal to logic 1. So when we compare the input terminal and the output terminal, the terminal with highest voltage will be the drain. So here it is only 0 volts. On the other side it is 5 volts. Therefore, the input side is mentioned as Vd. The output side it is mentioned as Vs because 5 volts is higher than 0 volts. Now, with all these assumptions in mind, let us make a simple calculation and try to understand why it is weak 1. So, assume Vg equal to VDD. VDD is equal to 5 volts. Threshold voltage is equal to 1 volt and we have to know what Vd is. What is Vd? We are trying to pass in logic 1 which is equal to 5 volts. Therefore, here I have mentioned as Vd is equal to 5 volts. With all these assumptions, let us calculate what Vds and Vgs are. VDS is equal to VD minus VS, that is voltage at drain minus voltage at source, which is equal to, what is the voltage at drain? It is equal to 5 volts. What is the voltage at source? Vs, right now it is equal to 0 volts. Therefore 5 volt minus 0 volt equal to 5 volts. We have to calculate VGS also, voltage at gate minus voltage at source. What is the voltage at gate? It is just equal to VDD, which is 5 volts. So 5 volt minus voltage at source is again 0 volts. So 5 minus 0 will be equal to 5. Right now, we already know that the condition to switch on Nmos transistor is VGS should be greater than or equal to VTN. What is VGS? From the calculation, we know that it is 5 volts. What is VTN? It is 1 volt. So 5 volt is greater than or equal to 1 volt. Right now, this condition is true. Therefore, Nmos transistor will be on. If the transistor switch on, this particular capacitor automatically starts charging from 0 volt to 1, 2, 3, 4 and so on. Right now, let us assume this capacitor started charging and reached 1 volt. Other parameters are left the same. VGG is equal to VDD, VDD equal to 5 volts, threshold voltage is 1 volt, everything are same, VD is equal to 5 volts. Again, we have to calculate VDS and VGS. What is VD? It is the same 5 volt minus VS. VS was initially 0 volts. Right now it is 1 volt. So 5 volt minus 1 volt equal to 4. Again we have to calculate VGS. VG minus VS, that is voltage at gate minus voltage at source. Voltage at gate is again going to be the same 5 volt minus voltage at source has changed. It is 1 volt. So 5 minus 1 equal to 4 volts. Again we have to check the condition to switch on Nmos transistor, which is VGS greater than or equal to VTN. We know that VGS is 4 volts. Threshold is 1 volt. So 4 volt greater than or equal to 1 volt. Yes, it is true. Therefore, the transistor will remain on. Still, the charge at your load capacitor should increase from 0 to 1. It has come. Right now from 1 to 2, 2 to 3, 3 to 4. It gradually rises. We are assuming the next case. Let us assume that Vc is equal to 4 volt. It would have risen from 0, 1, 2, 3, 4. Just for simplicity, we are assuming it as 4. Again, the other parameters are going to remain the same. Vg, Vdd, threshold voltage, Vd, everything are same. With the new values, let us calculate new value at the source alone. Let us calculate VDS. VD minus VS, which is 5 volts minus, what is the voltage at source? It is nothing but 4 volt. So 5 volt minus 4 volt, which is equal to 1 volt. VGS equal to VG minus VS. It is 5 volt minus, what is the voltage at source? It is 4 volt, which is equal to 1 volt. Again, we have to check the condition. VGS greater than or equal to VTN. What is VGS? It is 1 volt. What is threshold voltage? It is 1 volt. 1 volt is greater than or equal to 1 volt. Again, the condition is satisfied. Therefore, the transistor remains switched on. Let us increase some more. When we increase this 4 volt, when it starts charging above 4 volt. Now, when we increase the voltage slightly above 4 volts, it is going to pass this 5 volt completely on the other side. But when it slightly increases than 4, what happens? Let us see. All other parameters are going to be the same. Right now we have to calculate VDS and VGS. VD minus VS. Again it is 5 volts minus slightly more than 4. So we are assuming it to be 4.1 volt. What happens? VDS becomes 0.9 volts and similarly VGS become 0.9 volts. Again we have to check the condition to switch on the Nmos transistor, which is VGS greater than or equal to VTN. What is VGS? It is 0.9 volts now. But the threshold voltage VTN is 1 volt. Is really 0.9 volt greater than 1 volt? No. Now this transistor is going to switch off. So what is happening when I pass in 5 volts? Initially this capacitor was discharged to 0. When I started passing in 5 volt, this transistor was on. So this capacitor started charging from 0 to 1, 2, 3 and 4. When it reached 4, as even a slight value greater than 4 switched off this complete transistor. That is why we say that this Nmos transistor cannot pass the same 5 volts to the output. That is why we always call it as weak 1. Even though this 4 volt is considered as logic 1, but yet it is not a perfect 1. That is why we always call Nmos passes weak 1. Now let us look into the figure. Now you can see on the input side the swing is from 0 volt to VDD, that is plus 5 volts for our assumption. On the output side it is only from 0 to VDD minus VTN. What is VDD? 5 volts. What is threshold? 1 volt. So 5 minus 1, 4 volts. This particular capacitor was only able to charge up to 4 volts. So the swing will be only from 0 to 4. It will not reach 5. Thus, this particular Nmos transistor passes only weak 1. Now, let us understand how it passes strong 0. For the same figure, Vg is equal to VDD as we assumed already. Right now, we want to pass strong 0. Therefore, input should be 0 volts. So, it is 0 volt. Let us define whether this is source or drain in few seconds. For our assumption, again we are connecting a capacitor, but here this capacitor is pre-charged to 5 volts. In order to understand how it passes strong 0, we have to make this assumption that this capacitor is pre-charged to 5 volts. Now compare the voltage at both terminals. Input side it is 0 volts. On the output side it is right now 5 volts. Which terminal holds a higher voltage? The output side. Therefore, this becomes Vd, that is drain, voltage at drain, which is equal to 5 volts. The other input side becomes your source. Therefore, source voltage Vs becomes 0 volts. So, these are our assumptions. So, Vg equal to Vdd, where Vdd equal to 5 volt. Threshold voltage is again 1 volt. Vd is right now 5 volts. So, with all these assumptions, let us start calculating. Vds, which is equal to Vd minus Vs, which is again Vd. What is Vd? It is 5 volts. On the output side, it is 5 volts. So, 5 volt minus 0 volt. 0 volt is at your input Vs, which is again equal to 5 volts. What is Vgs? Vg minus Vs, 5 volts minus 0 volt equal to 5 volt. We know the condition to switch on the Nmos transistor. Vgs is greater than or equal to Vtn. It is 5 volt greater than or equal to 1 volt. Yes, it is correct. Therefore, this transistor will be switched on. When it switches on, this capacitor should start discharging, obviously, because it has reached the maximum volt. Let us assume it has started discharging and reached 0 volt at one point of time. Right now, with the same assumption, Vg equal to Vdd, Vdd equal to 5 volt, threshold voltage equal to 1 volt, and now Vd has become 0 volts. Let us put everything in the expression Vd minus Vs. What is Vd? It is 0 volts. What is Vs? Again it is 0 volts. So 0 minus 0, 0 volts. What happens to Vgs? Vg is the same Vdd value, which is plus 5 volts. So 5 volts minus 0 volt equal to 5 volt. What is the condition to switch on the transistor? Here Vgs must be greater than or equal to Vtn. So 5 volt greater than 1 volt. Yes, again the expression is true. Therefore still the transistor is on. But what happens to the charge of the capacitor at your drain terminal or your output terminal? It is 0. what is your input? The voltage at input is also equal to 0. Voltage at output is also equal to 0. That is why we call that Nmos transistor passes strong 0, because here also it is 0. On the other side also it is 0. That is the reason why we say Nmos passes strong 0. Look into the figure. The swing is from VDD to 0 volt. At the output also the swing is from VDD to 0 volt. So right now at this juncture, I hope everyone understood why Nmos transistor passes strong 0 and weak 1. Here are some advantages and disadvantages of Nmos pass transistor. First advantage is we need only less number of transistors to design any logic circuit. If you want to design an AND gate using pass transistor logic, it is enough to use only 2 Nmos transistors, whereas in CMOS logic we need 4 transistors. So number of transistors is obviously less in case of pass transistor logic, and it occupies less area, and Nmos transistor are comparatively fast when compared to PMOS transistors. So while using for pass transistor logic, instead of using PMOS transistor for the same, if you use Nmos transistor, the circuit will be comparatively fast. And the disadvantages, right now we have seen, it can only pass strong 0, but it cannot pass strong 1. So we are now clear about why Nmos transistor passes only strong 0 and not strong 1. We are now clear about it. So that is a function of an Nmos pass transistor. It has to pass, if the 0 is at its input, it has to pass the value whenever the gate terminal is activated. Similarly for 1. But it is unable to pass 1. Instead, it passes good 0. So with that as an idea, let us try to cascade some Nmos transistors. So now look into this figure. We have Nmos transistor where the output terminal is connected as the gate terminal of next transistor. Similarly, the output terminal of the second transistor is connected as a gate terminal of third transistor. Now what happens? When you look into the first transistor, we very well know that when I try to push 1 through the other side, that is logic 1, which means 5 volts, what happens? Only 4 volts are present at the output. This is what we have seen in the previous discussion. So what is the expression? V out is equal to VDD minus VTN. What is VDD? It is 5 volts minus VTN. What is VTN? Threshold voltage was assumed to be 1 volt. Therefore 5 minus 1, which is 4. Therefore only 4 volts will be present at the output. Now this 4 volt is the gate terminal voltage for the second transistor. So what happens? Again 4 minus 1, which is 3 volt. Only that will appear at the output, even though I have 5 volts at the input of this transistor. Again, when I give 3 volt, 3 minus 1, 2 volts. So when we try to cascade Nmos pass transistor in this fashion, we have multiple voltage drop. Therefore, it will degrade the complete functionality of the circuit. Therefore, we are not supposed to connect Nmos pass transistor in this fashion. There is another assumption. We can connect it serially like this. Yes, it is possible. Why? Now the input is 5 volts. What will be the output voltage? It will be only 4. 5 minus 1. V out is equal to VDD minus VTN. VDD is 5 volt. Threshold is 1 volt. Therefore, it is 4 volts. Next is again in series, but the control circuit is different because the control is 5 volts somewhere coming from the rail, not this 4 volt. Therefore, again 5 minus 1, 4 volt. Again 5 minus 1, 4 volt. So, there is no problem in having this kind of connection, but we are not supposed to cascade Nmos transistor in this fashion as shown in the table. So, I hope the working of Nmos pass transistor, of how it passes a 0 and how it passes 1 and why we say it has strong 0 and weak 1. Everything is clear now. Thanks for watching the video.